Okay, 5.3. Now when I get to the regular stuff, you really need to be on your A game. I'm going to do some review stuff first. First problem is we're taking an exponent expression. Now there's no adding and subtracting operations. That's a negative. So if I don't have any adding and subtracting operations, I underline the problem, create a fraction. So if I can move things to the bottom, if I need to, then I make 3 lines, okay? So everything's on top. What are your number bases? -4 and 2. Put the -4 in parentheses, okay? Then the variable bases, you just have x. Just write that once, though. You're going to add exponents because there are 2 of them. All that means is that you'll add the powers together. So -4 is to the first, but we have to distribute 3 to 1. So it's to the third. 2 is to the first, 6 to 1, that'd be 6. Now there's 2 x's. For the first one we distribute 3 to 2, we get 6. And then distribute 6 to 3, you get 18. 6 plus 18 is 24. Now, circle that exponent. Is it negative? I don't care if the base is negative. It's the exponent I'm worried about. No, it's not negative, so it stays where it's at. Then we got the 6 power on the 2. That stays where it's at. Positive 24 on the x, it stays where it's at. So really I didn't have to move anything. Now simplify your number bases. -4 to the third. You better get a parenthesis. If you're just going to use a caret key, you got to get a parenthesis around it. Or here's a novel concept. How about you just multiply it out? -64. When you have a negative base with an odd exponent, the product ends up negative. If you have a negative base with an even exponent, the product will be positive. 2 to the 6th, okay? Don't put 12, okay? Then x to the 24th power. Okay, now you should probably multiply these. No, it's not 0. You're not adding them, okay? You're multiplying them. -4096. And that's your answer. If the bottom's empty, it doesn't matter. So -4096 times x to the 24th power. Okay, next one. Parentheses 3x to the -4th. Okay. Again, there's no adding and subtracting operators on any of these, so I underline it and make 3 lines. Okay, so my number base I have 3, variable base I have x, only one of each, so there'll be no adding. So distribute -4 to 3, I'd be -4, and the same thing with the x. Okay, that's a negative power. You got to move it to the other side so it becomes positive. Don't keep it negative when you move it. That drives me nuts. Okay, you move it so it can become a positive exponent, and likewise with the x. Now, if you end up with an empty top, that's not good. You need to put a 1. You can have an empty bottom, but the empty top needs to have a 1 there. You can't have a bottom without a top. You can have a top without a bottom, but not a bottom without a top. And then I can simplify 3 to the 4th. Not the x to the 4th, but so 81 times x to the 4th. That's your answer. You need the 1 over it, though. The answer is not 81 times x to the 4th. It's 1 over 81 times x to the 4th. Okay, next problem. Parentheses 2d to the 5th, e to the -2nd, and the parentheses ends, and you have a -3rd power outside of it. Okay, so number bases, you got a 2. That's it. These are exponents, not number bases. Variable bases, you have a d, just one of them, and an e, just one of those. So no plussing, okay? Okay, that's 1, but you got to distribute -3 to the 1. -3 is distributed to all these. So it's going to be -3. 5 times -3 is -15, and then -2 times -3 is 6. Okay, that 2's got to move to the bottom so that the exponent can go positive. Same with the d. That exponent's already positive, so we keep it where it's at, e to the 6th. Okay, you can simplify 2 to the 3rd, that's about it. Okay, the variables stay where they're at. 2 to the 3rd is 8, it's not 6, 2 times, that's your answer. E to the 6th over 8 times d to the 15th. Okay, last one of these. We have a parentheses with 2e to the negative 4th power, and then g to the 5th on top. And on bottom we have e to the 5th power and g to the negative 3rd power. Again, this method can always be used as long as there's no adding or subtracting operators. Now that doesn't mean we never add and subtract. We do with the exponents, but the bases themselves, it's all multiplying and dividing. So I apply the properties. Number bases on top, you got 2. Variable bases, you got e. That's the only e you have on top. Okay, I don't even look at the bottom to start with. And then times g. So there'll be no adding. Now bottom, we don't have any number bases, but we got a variable base of e, only one of them, and a variable base of g, only one of those. So now let's figure out what the exponents are. 1 times negative 4 is negative 4. 1 times negative 4, negative 4. G's to the 5th. Now let's go to the bottom. Just a 5 and a negative 3. Now, when you have a bottom, you have to see if you have any common bases that you can cross out. Well, yeah, I'd cross out the lesser e, and then minus negative 4 from the 5. 5 minus negative 4 is the same as 5 plus 4, which is 9. So e's to the 9th. Okay. Now I have to do the same thing on the g. Okay. Cross out the one that has the smaller exponent value, and then subtract that from the top. Minus negative 3 again is like plus 3, which is 8. Okay, so I'm going to write what I have here. 2 to the negative 4th, e's been crossed out, times g to the 8th, then e to the 9th. Do you have to rewrite this when doing it on your own? No, and that's what you have. Okay, that's got a negative. You move it to the bottom so it can become positive. That's already positive, so you keep it where it's at. Now, I get a misconception on this e to the 9th. They'll say, oh, it's positive, that goes top. No, if it's positive, it stays where it's at. Because if you moved it to the top, it'd have to go to a negative 9, and I don't want that. Okay? Now, you got g to the 8th. 2 to the 4th simplifies to 16, and then times e to the 9th. Okay, next part. Find the zeros of the function. Well, that's pretty easy, okay? That's an F1, that's an F2, that's an F3, so there are 3 zeros to the function. You're solving for x. So x equals 0. Easy enough. X plus 2 could equal 0. Well, I'd have to minus 2 and I get negative 2. X plus 3 equals 0. Zeros of the function means y, the function, equals 0. So it's like putting it in factored form. What do we put for the y's? They're all zeros. Okay, there you go. Okay, this one. I know it's to the 3rd power, but there's only one parentheses, so there's only 1 0. So x plus 3 equals 0. X is negative 3. Okay, y equals x minus 2 quantity squared, and then times x minus 1. Okay, so that's F1, that's F2. Technically there's 3 of them, but that's the same one. That's a multiplicity. Okay, so it's going to be 2 that we find. So x minus 2 could equal 0. We add 2, and I get 2. Now, if I wrote a second one, it wouldn't change. It'd just be 2 again. So 2, x minus 1 equals 0. That'd be 1. Okay. 0, 0. Okay, y equals parentheses 2x plus 3, parentheses x minus 1. So 2x plus 3 could equal 0. Subtract 3, get negative 3. Then you divide by 2. I'm going to keep that negative 3 over 2. Then x minus 1 could equal 0. That would equal 1. 0, 0. Okay. Now to the meat and potatoes of today's lesson. You are factoring expressions, okay? But they're not quadratic expressions. It's not just x to the second power, okay? You're not solving an equation, you're factoring it. So you're not going to put your ABC. You're not going to put your ABC. You'll put a 1. Instead of ABC, you count how many terms there are. That's 3. 3 terms. When you have 3 terms, you set up your GCF, and then you set up your table, your T table. Now, I am going to bring in ABC to help me out, okay? But not from the beginning. 1, 12, and 64 would be 1. Look at the last term. You don't have an x, so don't put an x. And the first term right there, okay, that's positive, so my GCF's positive. Okay, if it's just 1, we get rid of it. Now I'm going to go to my ABC, okay, like I would with a quadratic. 1 times negative 64 is negative 64, okay? So how do you multiply to a negative? Well, it's a positive times a negative. And we have to add to the middle term, the B term, negative 12. 1 and 64 does not accomplish that. Divide by 2, you get 32. No. Doesn't even divide by 3. Divide by 4, you get 16. Bam. Okay? And I want it negative 12. See, I'm going to times these. And that's negative 64. Then I'm going to add these. And that's negative 12. So I know I have it right. Now, here's a part you can't mess up. You just can't. Put A equals, put 1, but put its x to the 4th with it. So that's all you need to look at right now. So if it's a 1, you can ignore it and just make 2 parentheses. But it's x to the 4th. So you don't put xx. Xx is not x to the 4th. That's x to the 2nd. X to the 4th is x second, x second. You split the exponent in half. Then you put the plus 4 and the minus 16. Now, you're not done, okay? You didn't do a GCF. Write these 2 parentheses up here. X squared plus 4, x squared minus 16. Now, these are both 2 terms. The one with a plus you can circle. That one's done, okay? You can put it down there. But the one with a minus, you have to see if these are perfect squares to go down further. Well, 16 is 4 times 4. X to the second's x times x. So yes, I can make another dots out of that with plus negative. That's why you got to line them up here. If it's a plus, drop it. If it's a minus, you see if you have if they're squares, they are x, 4, 4. Okay? Now, it's plus, you can drop that down. Now that has a minus, and 4 is 2 times 2, but the x is not to a power, so that's done as well. You can't break an x down without an exponent. There's your factoring. Okay? Next problem. X to the 4th minus 64. This time there are 2 terms. There's either going to be 2 or 3 on this assignment. When it's 2 terms, you set up the GCF just like you do with 3, but then you don't do your T table. You ask if you have a dots. So So 1 and 64 is 1. Look at your last term. Does it have x? No, it doesn't. Don't put an x. And the first number is positive, so the GCF is positive, so no. Now, dots. Well, you have a minus. Well, 64 is a perfect square. Get out your sheet. That's 8 times 8. You don't need to worry about the 1 when figuring out a dots. X to the 4th is x to the 2nd times x to the 2nd. So yes, that's a dots. I go x second, x second, x second, x second, then plus 8, minus 8. Now bring that over here, okay? Now you're bring this over here to see if you have any more dots. No, the plus isn't. You just bring that down, okay? Actually, bring it down on the line. Now, how about here? You got a minus, but 8's not a perfect square. No, it's not 4 times 4. 4 times 4 is 16, okay? That's not, okay? I can't write 8 as something times itself, so that just goes down here. And that's my answer. Okay. Next problem.